Okay, so I'm back here for part 2 of these notes. So as we finished up last time, we were talking about when we add a positive and negative number together. So our answer is going to have the sign of whatever there were more of. And if we think about this, the number part of our answer is going to be the difference between how many positives we had and how many negatives we had. So here we had 4 negatives and 9 positives. Remember, those 4 negatives here canceled out with these 4 negatives here, so that meant there were 5 positives left there. In the next one, we had 15 positives and negative 22 was our other number, so there are more negatives and there are 7 more negatives altogether. For the last one, we can tell right away that there are more negatives than positives, so our answer is going to be negative. If we want to find out how many, we have to subtract these two. Just think about how many more positives there are, and that's going to be the number part of our answer. We know it's going to be negative there. Now for these, you can use your calculator in this class, but we kind of want to remember what's happening behind the scenes so that we know when we get to some other situations where maybe we can't always use the calculator, we understand where those answers are coming from. Okay, so if we look at the next part, subtracting two numbers, let's again, you can use your calculator for this, but let's just quickly talk about what's happening behind the scenes here. So subtracting two numbers, we can think of it as adding the opposite, which means instead of subtracting a certain number, we can add the opposite of that number. Opposites are things like -5 and 5, for example. Okay, two numbers that have the same number part, but opposite signs. So here we have just a plain old normal subtraction, because it's a bigger number minus a smaller number. They're both positive numbers. So 14 minus 9 is going to be 5. If I think about doing it this way, adding the opposite, I could say 14, instead of minus, I would say plus, and instead of subtracting 9, I would add -9. Now, if you think back to what we had up here, there are more positives than negatives. There are 5 more. So in this case, we wouldn't really rewrite it because it's already sort of a standard subtraction, but that's what's happening. If we did rewrite it, we'd get the same answer. So here for this one, -45, instead of minus, we'd have plus. Instead of 5, we'd have -5. This gives us -50. And here, 20 minus, let's make that a plus. Here it's subtracting -4, so the opposite of that is adding +4. So we'd get an answer of 24. Okay, so when we're subtracting two numbers, when you first look at it, it might not be obvious what the answer is until you rewrite it. Okay, so let's move on. And again, when you're in class, any of these that you have questions on, we can definitely go over. So multiplying and dividing two negative numbers or one negative and one positive. So here is where a negative times a negative will equal a positive, or a negative divided by a negative equals a positive. And when we have one negative and one positive, if I have a negative times a positive, that's going to be a negative in either direction, no matter which one is positive and which one is negative, which one is first or second. And in the same idea, if I have two different signs when I divide, the answer is going to be negative. So if it's a positive divided by a negative, that's also going to be a negative. So I can summarize these by saying for multiplication and division, easy summary, same sign gives me a positive answer. Different signs, like a positive and a negative, always give me a negative answer. Now again, this is just for multiplication and division. We saw up above that if we have a negative plus a negative, we get a negative, right? But this is different for multiplication and division. So I'm going to pause the video. You can go ahead and just try these 6, and then when you come back, when you start, pause the video here, and then when you come back to it, you can check your answers. Okay, so after you've paused for a minute to try these, you can check your answers here. You can see that when we multiply and divide, if we have 12 and 3, let's say that we're multiplying, it's always going to be either 36 or -36. We just have to look at the signs. So these have the same signs, they're going to be positive. So you can check those answers. And again, if you have questions on any of this, let me know in class or office hours or whatever. All right, let's look at decimals for a minute. So again, we're not going to spend a ton of time because you do get to use your calculator. But when we're adding and subtracting decimals, we want to line up the decimal points. Okay, in what we're doing. Now, when we are multiplying decimals, we do not have to line up the decimal points. And the total number of digits after the decimal places, you can hear my cat in the background, in the numbers we are multiplying equals the number of digits, oops, after the decimal in the answer. Okay, so let's go back. Let me just do one of each of these and then you can try the other one as an example. So here we need to line up the decimal points. So I have 23.8 or 23 and 8 tenths, and then I have 5.79. So I don't want to put the 5 here. This is in the ones place, so I want to put that 5 here. And then to make it even, I can just put a 0 here. Okay, so then I just add. Just like I normally do, I carry over the decimal point just like I normally would carry. And we get 29 and 59 hundredths. Okay, so you can try this one in a minute. Let me just help you with something here. 15 does not have a decimal point in it. So where is it? Well, it's really at the end. So think about that when you're subtracting, and think about what we can fill in with here and how we subtract. And I'll go over that in a minute. I'll let you actually, why don't you go ahead and pause the video now and try it, and then when you come back, we'll do it together. Okay, so we need to fill in with zeros here. We're going to subtract 4 and 37 hundredths, so I line up the decimal places. Now, the biggest mistake I see, the most common mistake here, is that people want to do 7 minus 0. We can't do that. You always have to go top minus bottom. So I can't do 0 minus 7. I have to come all the way over here. This becomes a 4. What I did is I cashed in one of my ones places, and I'm going to make it tenths. Well, there are 10 tenths in a 1. That's how our number system is set up. There are always 10 of this thing in the next thing to the left. So if I still need some hundredths, so I take away one of these 10 tenths, and that makes 10 hundredths. So 10 minus 7 is 3, 9 minus 3 is 6, 4 minus 4 is 0, and then 1 minus the 0 is 1. When we move on to multiplying, okay, again, we do not have to line up the decimal points. So I can say, we can do a couple things. I could say 3.5 on top times 1.23. Often I kind of take the thing that has more digits and put that on top. I don't have to line up the decimal points. I just multiply as though there were no decimal points there. This is 15, this is 11, this is 6. Remember, we add a 0 here, or some people have learned to add an X because we're moving over to one place value to the left. 3 times 3 is 9, 3 times 2 is 6, 3 times 3 is 3, or sorry, 3 times 1 is 3. I add just like I normally do. Okay, now here's where this second part comes in. The total number of digits after the decimal, let's just say decimal points, not decimal places, after the decimal points in the numbers we are multiplying equals the number of digits after the decimal in the answer. So if I look at the numbers I'm multiplying, I have 1, 2, 3 total numbers after the decimal points. That means I need 1, 2, 3 numbers after the decimal point here. So my answer then becomes 4.305. Okay, if we look at number 2, we have 4.5 times negative 5. I'm just going to write 5 here when I'm multiplying. If I put the negative, I think it'll make me confused that I'm subtracting. So I'm going to multiply this just like I normally would. And I get 22. There's one number after the decimal here, so there's going to be only one number after the decimal here. But remember, because it is a positive times a negative, my answer is going to be negative. Okay, we're actually going to skip over the dividing decimals for right now. You can, again, use your calculator, but we're just going to set it up. So the first number is what goes under here. This is called my dividend. The second number is my divisor. Okay. The tricky thing about dividing decimals, which you'll notice with your answers maybe when you're dividing decimals on your calculator, is that if I have a decimal out here in my divisor, I have to move this decimal point over, and then I have to move this one over the same number of times. So this goes all the way to the end. Now my decimal point is here, which comes straight up. So essentially now I have 5 dividing into 57.5, then I can divide as usual. My decimal point's there, and then I would just divide as I usually do. So sometimes when you're dividing decimals or multiplying decimals, the number of decimal places you have might seem strange compared to the number of decimal places you had in your numbers. So again, if I look at where we were multiplying, here one number had 1 decimal place, this had 2, my answer has 3. So just don't get thrown off by that. Okay, let's move on to fractions. Adding and subtracting fractions. Again, this should all be review. We need to have a common denominator. So one way to get the common denominator is to multiply those together. If I multiply those together, I get 40. I also could use just any number that 5 and 8 both go into. So how do I do this? Well, now I want to say, okay, 5 times what gave me 40? Well, 5 times 8. So that means the top number also has to be multiplied by 8 for my new fraction that's equivalent. Here, 8 times 5 is 40. 1 times 5 is going to be 5. So now I have 24 40ths plus 5 40ths ends up being 29 40ths. Okay. Here I have a negative subtracting another fraction. So if you think about what we did, we can say this is going to be adding the opposite. I need common denominators. These can both be sixths. The second one is going to stay the same. The first one, this gets multiplied by 3, and this is going to get multiplied by 3. So I'm going to have negative 9 sixths plus negative 5 sixths equals negative 14 sixths. We can also reduce this. 2 goes into both of those. So I get negative 7/3. Okay, multiplying fractions. Again, these should be review. Multiplying fractions, we multiply across the top and across the bottom. Everyone wants to cross multiply. We don't do that when we are multiplying fractions. We do that when we have 2 fractions equal to each other. So we could say, I'm just going to rewrite this over here so there's more room. We could say 3 times 5 is 15 and 25 times 6 is 150. If we're asked to have it in lowest terms, 15 goes into both of these and I would get 1/10. Okay. Another thing I can do is if I rewrite this and start from the beginning again, if I have something in a numerator and something in a denominator that have a common factor, then I can cancel that out. So 3 goes into 3 once, 3 goes into 6 twice. 3 went into both of those, so I could cancel them out. 5 goes into 5 once, 5 goes into 25 5 times. Now I can multiply across 1/10. What I did was I really took out this 15 before I divided, or before I multiplied instead of after. When we're dividing fractions, we remember we keep the first fraction, we change my division to multiplication, and then we flip, so this is keep first fraction, we're going to flip the second fraction. Okay, so go ahead and try number 2 for the multiplying and the dividing one here. So go ahead and pause the video for a minute and go ahead and try those. Okay, so we see here for the second one, we're multiplying across the top and across the bottom. One's positive, one's negative. That gives us a negative answer. So we get negative 14/30. We can divide both of those by 2. They're both even, which gives us negative 7/15. Or if you like that method where we're canceling out, then we can say, well, 2 and 10 have a common factor of 2. So 2 goes into 2 once, 2 goes into 10 5 times,